Denn diese Stunde gehört Fernando Perez. Wir sind wahnsinnig froh, ich bin wahnsinnig froh, dass er heute hierher kommen konnte, dass er aus Berkeley gekommen ist und seine Projekte vorstellt, IPython, Notebooks und Jupyter, das neue Projekt, was daraus erwachsen ist. Was ich spannend daran finde, ist, dass das alles angefangen hat als Afternoon Hack, also als kleines Seitenprojekt, was man mal so irgendwie anfängt, weil es einem gerade einfällt, und dann gewachsen ist über die letzten Jahre und unglaublich spannend geworden ist. We are so happy to have you here. This is all yours. Thank you.
Hi. Thanks, Christina. I apologize for not delivering the lecture in German. My German is barely survival worthy. Thanks so much for inviting me. It's a pleasure to be here. This is not my usual community, and but I'm delighted to see these tools hopefully being useful to build bridges across different communities. A little bit about me. I come from a background of a fairly esoteric corner of particle physics, a corner that you may not have heard of, a part of particle physics called quantum chromodynamics. I did a stint in applied mathematics. I did a stint in neuroscience. The constant throughout my scientific career has actually been computing. And trying to build tools for helping us perhaps use computers to think a little bit better, to understand our ideas a little bit better, and to communicate a little bit better. And also, along the way, I've realized that if I wanted to build better tools for computing, that actually entailed having to build the environment around those tools. So I've ended up building not only software, but also building the institutions around that software. So I've also ended up building things like foundations and institutes. Recently, founding an institute, the Berkeley Institute for Data Science at UC Berkeley, and a foundation called Focus, which basically provides a legal framework for the development of open source scientific tools to engage both with academic research and industry, because it turns out that it's important to do these things. Very, very briefly, I'm going to give you kind of a very schematic, cartoonish picture of the hamster wheel that most of us scientists tend to spend our life running in. We tend to play with an idea. We have some data, we have some code, we have an idea that we think might be interesting, and we start playing with it maybe alone. At some point we realize that, I'm going to apologize that I've been a little bit sick and so more than once to drink water or tea. You may engage the collaboration of a colleague who has complementary expertise to you. You end up having to run those, if your idea is productive, you may have to run in a larger environment, you may have to take it to the cloud or to a supercomputer to run more data. If you're successful, you want to publish what you did, you want to communicate it to the rest of your community, hopefully your results are reproducible, and if you're very successful and those results actually stand the test of time, you communicate them to the next generation of scientists. And this is sort of the hamster wheel that we play in. And in scientific circles, unfortunately, between these steps, there's a lot of discontinuity. A lot of those steps are actually disjoint. You do this, and then you email stuff to your collaborator, and then you rewrite the code from a bunch of MATLAB scripts to a new version in C to run in the new environment, and then when you publish, you copy and paste a bunch of stuff into a manuscript that by the time you try to reproduce, the postdoc has already left and nobody has any idea of how it was recreated, etc., right? And what we've done in our project, in IPython and the project Jupyter, is try to think that this is actually one problem. This is not a bunch of stages, but this is a single problem, and that we should build tools that think of this as one single problem, and that only if we think of this as a unified question, then can we build tools that actually do the right thing. But what does any of this have to do with journalism? Well, for me, what it has to do with journalism is this quote that is a very old quote that I saw written on the door of my PhD advisor when I first started grad school, which was an old quote from a textbook by Hamming, a very famous numerical analyst, which states that the purpose of computing is insight and not numbers. And I think that applies equally well to scientists than to us. And if it was true in 1962 when they were worried that they were starting to have these things, newfangled things called computers that were beginning to crank out lots and lots of results really, really fast. and that all of a sudden they were going to get lots of answers that might not be relevant, and they'd have to stop and think. It turns out that that's obviously even more relevant today. And what we are trying to build with Project Jupyter is precisely tools for insight, tools to help us think, tools to help us play interactively, because insight does not come to machines. Insight comes to humans. And so what IPython and Project Jupyter are tools for you to play, to use the computer as an interactive, exploratory tool that helps you massage your data, that helps you use the tools, the computational algorithms, all of the libraries and the machinery that exists and that has been created by yourself or by colleagues of yours to play with your data and to explore your questions. And then, if insights do come to you, to communicate those insights, to collaborate, to work with others. And obviously, journalists are in the business of communicating ideas. And actually, that turns out to be the same thing that scientists are in the business of. Because scientists, at the end of the day, what we do is publish things. So it turns out that the final output of scientists and journalists is actually very much the same. What we do at the end of the day, scientists, is publish stuff. And what you guys do is publish stuff. So at the end of the day, we're not that different, you and I. So as it turns out, years ago, I wrote a blog post whose title was Literate Computing and Computational Reproducibility, IPython in the Age of Data-Driven Journalism. And so it was a blog post that I never thought I would find myself speaking to a bunch of actual data-driven journalists. So I wrote this about 3 years ago, 2.5 years ago, in my blog, where I introduced what I call literate computing, which was this idea of what it is that IPython and what this environment tries to provide as an environment, as a metaphor. And in there I was talking about an example that many of you may know about. Who has heard of Reinhardt and Rogoff in this room? A few of you, not all of you. So for those of you who haven't heard of it, I'm going to refresh your memory. So this is this is a screenshot from the BBC. Reinhardt, Rogoff, and Herndon. So this is Thomas Herndon, a graduate student at the University of Massachusetts. Reinhardt and Rogoff are two very famous economists, professor at Harvard and the ex-chief economist at the International Monetary Fund, who wrote a very famous paper in economics that made the argument that when the GDP to debt ratio of a country exceeded 90%, that debt ratio was basically unsustainable. And that once the GDP to debt ratio crossed that threshold of 90%, it was so catastrophically unsustainable that any measure would be justified because the economic consequences of crossing that threshold were so devastating that should be stopped. And therefore, the argument was used to justify things like the austerity measures that were imposed on Greece in Europe in the latter part of the 2006, 2008, 2009. And so this paper called Growth in a Time of Debt was published by these two economists, but they didn't publish their code and data. They only published their conclusion, this conclusion that was taken as fiat in economic circles for a while. And this student, at one point in 2010 or 2012, began trying to replicate those results as a homework assignment and just couldn't do it. He couldn't replicate them, and at first he thought he was making a mistake. And he started digging and digging and digging into it. And eventually, actually, his professors emailed the original authors and asked, hey, can you send us the actual data? Because no matter what we try, we can't get your results. And it turns out that when they sent them the original spreadsheets for the paper, there was a simple error in their spreadsheets. And they had missed in the spreadsheet a range of countries in the original computation. And the result didn't quite hold water. And if you included all of the countries in the computation, the result was not as strong as they had claimed. And in addition to that, there were also some other statistical arguments about how the other computations were made that probably could have used some discussion. Now, the point of that is actually not, the point of this is not to say that they were dishonest, because we all make mistakes. We all make mistakes. This is part and parcel of science. The point is that if we make sharing our tools, sharing our code and data part of the process of how we conduct science, these things can be caught as a routine matter of how we do our work, rather than years later, after much deeper consequences have been enacted. And so once, when this student published these results, I said I pinged the internet and I said, hey, would somebody actually make that analysis available as a notebook? Because this seems like a very interesting thing to actually decompose and reconstruct as a notebook. And within a day, somebody had replied and said, here you go. There it is. Go ahead and here you go. And so this fellow, Vincent Ariel Bundock, who was a graduate student at the University of Michigan, published an entire IPython notebook replicating the complete results with the code and the data in a GitHub repository. So what is an IPython notebook? So this is what this fellow this is what Vincent Ariel Bundock published. This is what's called an IPython notebook. For those of you who are not familiar, an IPython notebook, what he used is this document that looks kind of like a word processing document. There's text, there's a title, there's a bullet list, there's some hyperlinks that you can click on, and if I was on the internet, it would take me to it. But there's also code. There's blocks of code in here. And there's an analysis here, and when this executes, it produces a result. And then there's more code, and here there's the result, there's statistical result of the analysis. So what he did was he actually went through all of the analysis of the corrected analysis for the Reinhardt and Rogoff result. This is an IPython notebook. So to give you a very quick tour of what the idea of this environment is, it's a web-based interactive computing system that allows you to mix code, results, and narrative in a single document. So you can think of it like a word processor, but it's a word processor that also contains live code execution and that you interact with through the modern web browser. And so you can define a little bit of code, and you can execute it, and it'll produce a plot right there. In this case, a very scientific-looking plot. But you can also add, oh, I want to interact with that plot. And I want to interact with that plot, in this case, if you say that I want to interact with it, now here I get graphical controls. So if you want to play with the parameters of something that you're doing in one of your analyses, all you have to do is say, I want to interact with it, and say which parameters you want to interact with, and then without having to write any more code, you will get little controls like this. So with one line of code, I'm not a professional programmer, I'm a physicist. I'm not trained as a professional software engineer. But I'm willing to write this much code to get a little bit of graphical control to explore the parameters of a problem, just so that I can see, instead of typing over and over something, so that I can play with the parameters of my analysis. You can document what you're doing. You can type in here. This is basically, you can have italics, you can have boldface, you can have lists, you can have, and then when you get out, it's nicely rendered. You can have mathematics. So you can type arbitrary mathematics and it gets rendered, which obviously for scientific content is very important. You can execute arbitrary code that's loaded off the internet. So if I was connected to the internet, I could type a command and this would load a remote code from a remote server and it would load it in here. I did this in advance so that it would work without the internet. And here we have code rendered with XKCD styling for those of you who are XKCD geeks. More importantly, we've taken the idea of code executing in a web browser really sort of to its ultimate conclusion. And so when we execute results, the output can be anything that a web browser can render. So in this case, I can say, give me an image. And an image object actually displays, in this case it says output. Output is the actual displayed object. It doesn't say a string representation of an image, it gives me a displayed object. And here I can have as an output an HTML object, which gives me a rendered HTML table. So I can display anything that a modern web browser can display. And this is extremely useful because it means that modern web browsers are very, very sophisticated pieces of technology. And it means that as you work with your computations, you can be loading your data and you can get back out things that are very easy to work with, very interactive, and that render taking full advantage of the capabilities of the web browser. So this is an example. This is actually not going to work. If I try to run it right now, this would fail because this would try to load using the web, the web data reader module from the Pandas library, it would try to load the Microsoft stock data from the Yahoo Finance model, from the Yahoo Finance stock data sources, and then it would actually plot the closing price. But I ran it in the hotel before, and this is what happens. I get a nice little, with 3 lines of code, I can get the plot and a summary table of the Microsoft stock price. This is, when I say display stock column 3, I'm saying show me the first 3 lines of that table, right? And I get a nicely formatted HTML table of that data, right? I'm getting something that displays naturally in the web browser. And then I say stock, close, and plot it with the title closing price. And I get a proper plot of the closing price. So you can work in an environment where everything comes back to you in the most natural way that the web browser can show. Here's an example of an object that is sound data, and sound data can be represented in the time domain, in the frequency domain, or as audio data.
How much wood would a woodchuck chuck if a woodchuck could chuck wood?
So this is the same piece of information can be represented in 3 different ways. So the idea is that as you're working with your data, you can choose what is the most sensible way to represent the information to your users or to yourself to visualize it, and you can encode that representation in any way that you want. You can represent embedded video, because it turns out that web browsers today can display embedded video quite nicely. You can represent YouTube video. So we have an object called a YouTube video, and if you simply pass it the hash of the YouTube video, it'll display an embedded YouTube video. You can embed an entire iframed website. So this is the Wikipedia website, and it'll embed actually an entire iframed website. Mathematics, so you can embed mathematical expressions that get rendered not only if we type math, but the actual result of a computation. And the reason why this is useful is because sometimes there are libraries that return objects that are computed mathematically. This is particularly useful, obviously, for symbolic, for people who do physics and mathematics and things like that use libraries that compute mathematical expressions. And in Python, there is a library called SymPy that allows you to do things like type an expression and then ask you to do symbolic manipulations of it. And so this is a very quick tour of it. I'm not going to spend hours demonstrating it, but this gives you a very quick sampling of the idea that you can create a document that mixes code, narrative in plain English, right, where you can type arbitrary text in plain English, right, with arbitrary HTML, and pretty much any computational output that a web browser can represent, taking advantage of all of the modern JavaScript libraries. So D3, pick your favorite JavaScript framework of the day. You can use it in here and couple it to your computational backend in Python or any of the programming languages that we serve. And so this is what the IPython are now known as Jupyter Notebook environment is. So very quickly, going back for a bit of history. This all started around 2001 when I was a graduate student looking to procrastinate on a dissertation, and it didn't start like that. It wasn't this fancy. What I'm showing you is 15 years later. It started as something that only ran in a terminal. It didn't have all these fancy graphical features, but it let me procrastinate on my dissertation for a while, hide away from my advisor, and it did let me get an environment that was basically a better shell for running Python code and run my analysis. And I was trying to basically shift away from proprietary tools for the analysis of my physics codes and start doing them in Python. Fast forward from what began as just an afternoon hack in 2001 to around 2014, a project that had grown to hundreds of contributors and hundreds of thousands of lines of code. Obviously, this project now has a very large community. It's not my work anymore. All the real credit goes to. We have over 500 contributors now in the project, and they really deserve all the credit. We actually, interestingly, get most of our funding from private foundations and from industry. We have received very, very little government funding, and in the US this is weird because most academic research in the US is government funded, and we have had very little of that. Most of our funding has been from the Alfred P. Sloan Foundation, the Gordon Betty Moore Foundation, the Helmsley Trust, and contributions from industry who have been very interested in the project. Architecturally, what the project does, for those of you who are interested in how it works, is what we did was we took this idea of typing code in a terminal, what is known as a REPL. A REPL stands for those of you who are geeks and who may have heard the word REPL. REPL means read, eval, print, loop. It's what happens in a terminal. You read input, you evaluate it, you print it, and you keep looping. You keep doing that over and over. So what we did in IPython is we took that idea of what ran in the terminal, and then we abstracted that into a protocol that ran over the network. And then we said, once we've abstracted that idea of evaluating code over the network, we can put that and run it anywhere. It doesn't have to run in the terminal. It could run here, and the client code could execute somewhere else. And at first, around 2010, we wrote a client, which was this thing that looked like a terminal, but was actually a graphical console that already let us do a little bit of notebook-like things, such as running a bit of code and having an embedded graphic result, a plot displayed right in the terminal, which you cannot do in a normal terminal. A normal terminal will not let you do that. And this was already progress. And then in 2011, we released the first version of the notebook that I just showed you. This immediately became extremely popular. And the project then began to evolve from what was originally called IPython into what now we call Project Jupyter, which was taking this architecture and making it language agnostic. The core of the architecture is this idea of having the kernel executing the code, communicating over a network protocol to any number of clients, a console that can be, we still actually have a plain terminal because sometimes it's really useful to talk to something just from a terminal. That's still very useful in many contexts. We have that same Qt console, graphical console still exists, the web notebook that obviously is kind of our major product. There's actually other clients that exist that serve more specialized purposes. But then what happens was, the original kernel that was written for the Python language, well, we realized there's many other programming languages out there. Why not write languages in kernels in other languages? And so people began writing kernels in many other languages. And actually this number is outdated. It's not 37, it's more like 50 now. And so people began writing kernels in many, many other languages. And so obviously the question became, well, why is it called IPython if it works for all these other programming languages? And so what we said was, well, let's look at what the project does. The project has tools such as an interactive Python shell, a kernel for this abstract protocol that works in Python. We also have some tools for interactive parallel programming in Python. And then we have all these abstract tools for network protocols, all these clients, all these tools for managing the notebooks that are abstract and that are where the specifics of the programming language don't matter. And so what we said was, everything on the right, where the specific programming language doesn't matter, will become what's called Project Jupyter. And it's basically tools for interactive computing across programming languages, where the specific programming language that is being used may be irrelevant, or where we want to unify across communities. And IPython will become one of the projects in that ecosystem. And it'll be the project that has the tools that are specific to the Python language. We are still mostly Python developers. We use the Python language, and we continue developing the Python tools in that kind of block. But in the Jupyter project, we maintain everything that is language agnostic. The name is inspired by Julia, Python, and R, which are the three kind of open languages of data science, but it's not an acronym. We pay homage to astronomy because astronomy has been a very important player in open science and in the rise of Python as a viable kind of data science language. We had a long and very fruitful collaboration with astronomers in the history of scientific Python, and also to Galileo's original notebooks. If you actually go back and read Galileo's Sidereal Messenger, published in 1617, when he was observing the moons of Jupiter for the first time, basically his notebooks were sort of the first open notebooks of open publications. He actually had sort of his code and his data. He had all of his observations, all of his metadata. He had the location of the moons very carefully put out there. And there was a beautiful blog post from the authors of the creators of Authoria about how Galileo's notebooks kind of embodied those ideals of open science back then that we have sort of lost. And so we thought it was that it was kind of a good way of paying homage to that idea as well. This ecosystem has continued to grow in the scientific community. One way in which we've tried to help that growth is by providing a service called the Notebook Viewer. NB Viewer is a service that allows you to simply paste that allows you to paste the URL to any notebook anywhere on the internet, and it will render it for you. If you actually go there right now, it's a good thing that the internet here is having problems, because as of this morning, we've been having a very weird glitch with the service that we haven't been able to fix. So I don't know what's going on, and we're looking into it, but we're having a very bizarre failure with the server. But except for today, it's a very, very popular service that allows you basically to share a notebook with anyone without having to give them anything special. All you have to do is put it anywhere online, and you paste the URL to the notebook into it, and it renders it for you and gives you a rendered version as HTML. That way you can share with your colleagues the rendered version, and they can see a nicely formatted version in HTML instead of having to install any software. So it made, especially in the early days, it made it very easy for people to see what notebooks would look like, because otherwise the notebook itself as a file is actually a JSON data structure on disk. So if you look at a JSON, at a notebook file, without the right software installed, you wouldn't be able to see anything that makes any sense. So it made it very easy for people to post a notebook, and then they would post the Notebook Viewer link on Twitter, for example, and they would say, I did this. And they would share that link with other people, and people would immediately see the results nicely rendered. And we would see the spikes in traffic whenever people would post an interesting result that would be popular. We would immediately see in our logs the spikes in traffic. We started using these tools for sharing research that we made reproducible. This is an example of an academic paper. That we published where in this case it was a microbiology paper, basically parallelizing analysis of certain classes of microbiology results. But in addition to publishing the original paper, what we did was, together with the paper, we published the IPython notebooks and the Amazon virtual machine images that would allow you to boot into the paper and execute the notebooks replicating the results. And so this was back in 2012, trying to basically push people towards the idea that with these tools, they could actually see the complete execution environment that led to the scientific result as a way of encouraging this notion of reproducible research. This is now becoming fairly standard, but back in 2012, when we first did this, people didn't think that this was such a normal thing to do. And when we say publishing, it doesn't necessarily have to be only the peer-reviewed literature. Scientific communication in other ways is just as important. So this is an example of a scientific blog post. This is from the Scientific American blog, a blog post written by Jake Vanderplas about visualizing the distribution of asteroids in the solar system. And this is one figure in the blog post. But if you actually go to the bottom of the blog post, you'll find a link that takes you to a notebook that contains the exact same figure. So actually, the whole blog post is written as a notebook. And so on the Scientific American website, you will see the blog post formatted in the format of the Scientific American blog, and it's presented in a certain order. But if you actually hop over to the notebook version, it actually has the code that generates every single figure in the blog and the actual functions that produce the blog. It's just that it's in a slightly different order, and you can actually execute it. So Jake is basically encouraging you to say you can read it here on the Scientific American blog post, on the Scientific American blog, and comment within the Scientific American platform, or you can go to GitHub and view the notebook version up on GitHub and download it yourself and execute the analysis yourself. This is now not just a single blog post, but an entire book. This is a Springer book, nice hardcover, glossy paper, traditional academic book, but where every single chapter of the book was actually published as the author developed it, was published as a notebook, and as the author was doing the work, he published them on his blog. So he would write a book, he would write a chapter, he would put it up on GitHub, and he would put them on his blog so that he would get feedback from people. And then once he was done, he formatted them, he did some manual processing, and he compiled them into a PDF that he sent to Springer. So yes, you can go to Amazon. You can go to Amazon and order this, and you will get, I have a copy of it, and you will get a paper copy in the mail. But you can also actually go to GitHub and clone this repository and get an entire fully executable book where you actually have, you don't have to wonder whether the author copied and pasted the examples right, because the entire book is a collection of notebooks that are you're actually executing the book basically. And that's not the only one. There's actually a few other authors who are now starting basically to follow this way of working. There's now a growing contingent of university courses that are starting to be deployed in this manner. An interesting one that I like to highlight is an open MOOC being taught collaboratively by Lorena Warba and some of her colleagues on numerical methods, and where they've done beautiful work with the typography and the presentation of the educational materials about that. But actually, I should have, I know that there's a couple here. The fact that I was just so sick for the last couple of days. The projector is not all that great. These four are from the Columbia Leedy program on data journalism, led by Chris Wiggins, who's the chief data scientist at the New York Times. So these four are all IPython notebook-based courses and I know that all of the materials for these guys are up on GitHub. There's books about the system where all of the materials are available in this format. And we've actually been working with academic publishers to begin changing the culture of academic publishing. So this was an example of something that we did with the Nature Publishing Group, where Nature did an interview with the team about how these tools could be used for sharing code and data about an academic publication. And then what they did was they actually put up a demo so this is a demo on the Nature website, hosted directly on Nature, that has an actual IPython notebook right there that is hosted on the Nature website, and that I can go ahead and execute now. Because I don't have an internet connection, I'm going to run the same thing locally instead. But if I run it locally, this is what I get. And I can play with the code. I can play, for example, play with parameters. I mean, the usual thing. We added because the idea was to illustrate what would something like a somewhat reasonable scientific result look like. We added an example using cyclic image of one of the most iconic images in astronomy, which is the Hubble Deep Field image, when the Hubble Space Telescope was pointed at a single location in the sky for a long time, and it collected light from a single location. And so you can actually play with the parameters of a cluster detection algorithm and see what do you detect as galaxies. So as you change the radius and the threshold of your detection algorithm, you can see what does the algorithm detect as galaxies in the Hubble Deep Field. And as I'm playing with these sliders, I'm actually well, not right now because I'm running the copy on my laptop because I don't have an internet connection. But if I was doing it on this tab right here, I would be doing that here. I'm sorry, here in the Hubble, the Deep Field one. I would be doing that on the Nature server. So the idea was to show to people that you could publish a scientific publication with the code and the data, where the readers could not only view the results, but they could actually interact with the results, and they could explore parameters beyond or at least around what the authors had provided. We worked with Nature, asking them roughly what server capacity we should prepare for this, and they gave us some estimates based on their kind of readership numbers in general, and we thought we had done a good job over preparing beyond that, and in the first day we completely crashed our survey because it was actually one of the most popular articles ever in terms of readership numbers, because people really want to play with this kind of content, and we actually kept it up. This continues. We decided just to keep it up at least for the foreseeable future, because it continues to be a very valuable demonstration that this way of presenting academic content and scientific content can be a useful way of changing models for presenting publications. Whether that'll be the future, I don't know. We'll see. So back to you folks. So 538, I'm sure, is something that is familiar to all of you. I don't know what kind of standing it has in your community. I'd love to hear from you. This is a specific case of an article that they published in April of 2014, where they published an article on their website about the Bechdel test, about gender disparity in Hollywood movies, and they had some conclusions about that. No data. And so Brian Keegan, who at the time was a postdoc at Northeastern University, published this. He published a notebook, an IPython notebook, basically telling 538, hey folks, that's not cool. You claim to be, let me show you what he actually did. So this is the epic notebook that he published. He went on. So they published a couple of conclusions, and they didn't publish any code, any data, nothing. This is 538, supposedly the standard bearers of data-driven journalism. And so Brian Keegan comes out and look. He went to town on them. He just, this epic analysis. He went and collected data. He found all the data. He did tons of analysis. And he just, I mean, he really did a job on that. He really, really did a job on that. Pages and pages and pages and pages of analysis. The guy's good. Brian Keegan is extraordinarily good. He's a social scientist. He's at Harvard now. Extraordinarily good. And so after he did all that, and he basically didn't leave anywhere to run, he said 538 and similar sites should make their data available. And to their credit, in their blog post, they said, we're exploring ways of making our raw code and data available to our readers, and to their credit, they did. So afterwards, they actually changed. They didn't go defensive. After Brian Keegan posted that gigantic epic notebook, where he basically recreated everything and more with much more nuanced analysis, with a much more sophisticated statistical thinking than anything they had ever done in their article. They actually went and posted their code and data. So. And finally, a recent example from a week ago, so that I thought would be very timely. So this is an article from the Los Angeles Times of where a couple of reporters from the Times were analyzing data from the LAPD, and they were finding that after doing some Freedom of Information Act requests, I think, and collecting the raw data, they did some machine learning analysis to find that they were underreporting the seriousness of some of the crimes in the district of in LA County, and so this is the actual public article in the LA Times website. This was I think October 20. I think it was like a week ago or something. And this fellow Anthony Pesci, who's one of the three authors of the article, or one of the four authors, if you hop on to GitHub, he is the one who did all the analysis. So you can go up to GitHub, and you can find all of the code and all of the data and all of the notebooks that have all the analysis backing backing the article. So I guess the LA Times is now considering this to be sort of first-class citizen material to back up how they construct some of their analysis. Jeremy Singer-Vine from BuzzFeed was the one who alerted me to the fact that they were doing this, which is great. So it's on GitHub. Datadesk is the account on GitHub. So the big picture of these workflows is that basically around these notebooks, you sort of do this. Oops. You have this sort of iterative exploratory workflow with these documents where you may be pulling in data, you have your CSV files, you're pulling data from databases, you may be pulling data from online sources like I ran that query, or I would have run that query, pulling in financial data from Yahoo. And you can be hosting them on GitHub, and then from these notebooks you can be exporting them to HTML, to PDF. These things can be converted to any format that you want. You can be sharing them via NB Viewer, as I mentioned before, with collaborators. But this is the environment where basically you have sort of the exploration and the insight mining of your team. And this is sort of what we're finding. People are doing a lot more. We have a gallery of IPython notebooks on our wiki where you can go and sort of see what many other people are doing. The project has grown a lot. We also have other pieces of infrastructure that can be of interest for larger organizations. Jupyter Hub, for example, is something that allows you to deploy a hosted instance that allows teams to run Jupyter notebooks with multi-user support, with authentication, with containerization, sort of in complex environments. And this is something that in larger organizations may be of interest. At UC Berkeley, for example, in the spring, Jess Hamrick, who's a grad student at Berkeley and one of the members of the project, did a very sophisticated deployment using Rackspace hardware to run a class, where she had about 200 students and was able to isolate them all and do homework management and deployment with that. And it was so successful that this was now adopted by the new Data 8, which is UC Berkeley's new Foundations of Data Science, which is going to be offered to every incoming freshman at Berkeley for basically for the future. So this is now being deployed campus-wide at UC Berkeley using Jupyter Hub. And now there's actually many other universities who are using Jupyter Hub to do deployments, institutional deployments. These tools are being adopted in many other places in industry as well. So there's a new product from IBM called the Data Scientist Workbench, which is basically a rebadged Jupyter. Google just announced last week. I'm pushing two buttons at the same time. Google announced last week the Google Cloud Data Lab, which is basically hosted Jupyter notebooks on Google infrastructure. They also have the Google Collaboratory, which is real-time Google notebooks. O'Reilly has a product called Phoebe, which is a very interesting project for basically doing lightweight Docker-based containers for kernels. That is very interesting. I don't know why this keeps jumping. Microsoft has notebooks integrated into their machine learning on Azure framework. So companies are actually building quite a bit of infrastructure around this as well. So just to wrap it up and leave a little bit of time for questions, hopefully, and discussion. Hopefully, it's clear that the notion of communicating narratives that have a lot of computation and data is actually, I've made a compelling case that it's something that joins both your communities and ours, that it's something that exists across both our worlds. Hopefully you've seen that our tools are open. They're fairly mature. They have their bugs. They have plenty of bugs. They have plenty of problems. But they're open. They're open source. You're welcome to not only to use them, obviously, because they're free and they're available to you, but you're also welcome to contribute. You're welcome to fix them. We'd love if you contribute, but you're welcome to use them, certainly. And we'd love to have a dialogue with you. I'm sure that there's a lot that we can learn from you. I'm also very interested in what we can do as scientists in engaging society better. I worry a lot about what happens as we move into a society with ever increasing challenges that are where society has to make decisions that rest on a better understanding of complex issues where data and scientific issues matter, and we have a populace that doesn't understand those things. And I would like to believe that some of these tools can help a little bit, but I also know that people like journalists are often the bridge between our work and the rest of society, and so hopefully a dialogue with your community could be a productive one. And I'd like to leave it at that. Thank you for your attention, and if you have any questions, and I don't cough myself to death, I'd be happy to take some questions.
Hi. How easy or how costly would it be for a magazine to host their own kernel, and how easy is it to turn the geeky, nerdy notebook into something publishable by some?
So those are two different questions. Hosting your own journal is
kernel, not journal. Sorry.
Oh, I'm sorry.
Hosting your kernel on your own, your notebook.
User gets their own kernel.
Yeah.
That's.
Oh, sorry.
I totally misunderstood.
If you're a magazine and you want to publish an interactive story with a kernel hosted somewhere under your control, how hard is it to do? How costly is it to do?
It's fairly straightforward, and for that, O'Reilly has solved most of the problems with Phoebe, because they've basically done all of the work with Dockerizing the machinery for that. So I would look into Phoebe. There, the only constraint is really for how long does the kernel run, how much computation do you allow it to use, and how big is the instance in which it runs, because when it gets instantiated, it'll run on some hardware, and you probably want to do that in the cloud, and you want to run that on Amazon or Google Compute Engine or Microsoft or some cloud provider, right? And so, but the good thing about that is that you probably select those things, and you do that by assigning it fairly hard limits, in that you do it with a completely anonymized container that is destructible, that is meant to be destroyed once it's idle, and you probably also force that it's destroyed after a finite amount of lifetime as well. So you have pretty good control.
I noticed this headline in the Brian Keegan article you showed, that data journalism should emulate the openness of science. And do you think that because data journalism uses scientific or quasi-scientific methods, it has like a stronger responsibility to be transparent and open than traditional journalism?
Well, I hate to use science as an example of anything, to be quite honest with you, because I actually think that there's as a practicing scientist, I think there's a strong difference between the ideals of science and the practice of science. I think, yes, the ideals of openness, reproducibility, and replication of science are ideals that are very valuable. And that are extremely important, because they are basically what makes science a self-correcting enterprise. And that, in and of itself, is a really fundamentally important principle that I believe in. The practice of science is often a murkier enterprise, and I think it's important to distinguish between those two, because a lot of what we fight in science is because science isn't as open as we would like it to be. Just today, one of my postdocs sent me an email saying that the Wellcome Trust in the UK and the National Institute of Health in the US actually launched a joint initiative with a new prize called the Open Science Prize, we wouldn't have an Open Science Prize. There wouldn't be a prize for open science if science was as open as it needed to be always, right? These agencies wouldn't be creating prizes for open science if science was perfectly open, right? So the fact that, and especially the fact that these are the health and life sciences funding agencies is indicative that in the life sciences is an area where science is probably not as open as we would like it to be. But having said that, I do think that the idea that openness and transparency helps, the fundamental idea is that openness and transparency helps us be self-correcting. That as a principle is a fundamentally good principle. It's also a principle that probably is going to have to be balanced against other things. It can't be an absolute. And for example, I remember that at the event where we met, there were some very interesting discussions coming from folks in journalism who said that, well, you often operate in circumstances where you have constraints of privacy regarding, I mean, in science, obviously, there's sometimes privacy regarding to where the data is acquired, but in journalism, there's sometimes very difficult privacy constraints about human rights data, how the data that could be people's lives at risk, and much more sensitive issues. And so transparency cannot be an absolute. But at least remembering that the notion of openness is about making the process a self-correcting one can help you reason about that, I think.
Hi. So I'm a big Jupyter fan. I use it for my data analysis. And I also actually just ran a workshop where I ran Docker containers so everyone could have a notebook. But my question is about, are you aware of the R Markdown format, where basically they embed R into Markdown, which you can actually view without a viewer, just with an editor. So is there ever going to be something like that for the IPython notebook format or something like that? Because you can't view it without an editor, and that sometimes it's frustrating to me, especially with version control and seeing diffs and stuff.
Yeah, so there's a fellow in I can't remember if he's right now in Paris or in London, Cyril Rosson, who's the author of the 2 books on IPython. So when he was really frustrated with the workflow for writing his books that was word-based, and he wanted to write them in notebooks, but he really wanted a better version control workflow. So he wrote something called IPyMD, IPython MD, which is effectively R Markdown for notebooks, that more or less gives him that. And it's basically notebooks in Markdown. So yes, IPyMD.
Very cool.
And we actually are probably going to be putting a lot more work in that direction over the next year. So, I mean, Cyril's work is already a great first step in that direction, and we're going to continue working in making the version control workflow much better, because we know that's probably our biggest weak spot right now. It's a disaster and it's an embarrassment. We know it. It's really bad.
Concerning science and openness, maybe you know that journal PLOS One, which is
Mike Eisen is at UC Berkeley, so no.
Okay. Yeah. So that is dedicated to open science, reproducible science. And I looked at it once, and I looked at quite a couple of studies that were using Twitter data, and I couldn't find a single paper that actually published the data they used or the methodology behind their reasoning. So in my opinion, or from my viewpoint, it's still very, very rare, seldom, that scientists actually publish their methods. And what do you think, what's the reason for that? And will tools like Jupyter Notebook, will it help scientists to make it better? Do they actually use it, or why not?
So you're absolutely right, and I think the reason is incentives, that no one is incentivized to do that, and we're trying to work with publishers in changing that and doing things like adding reproducibility badges to publications and adding reproducibility criteria in the review of publications. It's a long slog in changing the culture of scientific publications to get us there. But at least one of the things that I've done, for example, is track in the IPython gallery. there's a section of the gallery that's called Reproducible Academic Publications. And you can see in there, it's a list. Unfortunately, it's manually curated, so it's not very up to date, because it's whenever we notice something interesting, we go and put it up there. But we track papers that have been done where the authors have accompanied the paper with one or more notebooks that create all the results in the paper. And there are some amazingly good ones. There's in particular, I can't remember, like the fourth of the fifth one in that list, is a ridiculously well-done paper in Nature Genetics of 2014 about head and neck cancer. And it's incredible because the paper embodies, in my opinion, it's one of the papers that embodies best an idea that David Donahoe's 1995 paper on reproducible research stated very well. David Donahoe in 1995 said, and I'm paraphrasing here, that a modern publication, a modern scientific publication should not be considered scholarship anymore. The true scholarship is the complete environment, software, code, and data that creates the results. And the publication should be considered an advertisement for the scholarship. And the quote is very concise. It's in his Wavelab and Reproducible Research, Bauckheidt and Donahoe 95 paper. And it's a very, very nice quote about that point that I like a lot. And that paper does exactly that, because if you go and look at the paper, it's a Nature paper, super high profile, very well done. But the paper, like all Nature papers, 6-page limit, right? Very short. And it has in the officially linked supplementary materials, they link to a GitHub repo of IPython notebooks. 20 notebooks. And those 20 notebooks are super well organized with a README that is an index of notebooks, one after the other. All 20 of them are very documented. They're not sort of sloppy, just thrown together. They're very documented. And those 20 notebooks recreate every figure, table, and result in the paper. So basically, it's exactly that, right? The paper is a summary, and those 20 notebooks are really the reconstruction of the entire research. And that's, in my mind, what a paper should be, right? You read the paper to get the quick summary. And if you really want to see what happened, that's where you go. You clone that thing, and you start from that README, and you go one after the other, if you really want to work on that topic. And that's where we should go. That paper is my prototypical example of where we should get with academic research. Okay. It's number 4 or 5 on that list.
I pretty much share your own opinion on that. I really think that's really helpful and useful. But then, is that actually used? Are those GitHub, are those repos actually being forked and reproduced? Is that?
It's a good point. I don't know. I'm not online, so we can look at it. We can look at it after the break. We can just go and look at it. It's a good question. And we can actually. It's a really good point. We should, for example, contact those authors. It's already a 1.5 old paper, and ask them, what has the impact of that been? Have they gotten any feedback on those? Has that had at least any follow-up? How do they compare that to other similar work they've done, at least?
Do you think that stories have to be reproducible as well? And could the IPython notebook help to make stories more reproducible?
The question was,
should
stories be reproducible?
I'm not sure that I understand what you mean by a story being reproducible.
In journalism.
Yes, in journalism, yes.
Do you think that stories, or for data journalists should be reproducible? And could IPython Notebook help to make the stories more reproducible, so other people can see what you have researched and which data you used and how you used the data? What do you think about that?
I mean, I think so. In this sense, yes. In the sense of this story, yes. For example, this story from the LAPD crime statistics, right? They published their code and their data here. And you can go and clone that repo and reproduce the analysis, because what that gives you as a reader is a chance of actually seeing how did they do the analysis, right? You can replicate it, and you can at least argue about whether this analysis is correct or not, and start from there and have a much. I think we can have a much more educated and much more sophisticated conversation from that point on if we have access. If we have access to this level of information, I think the conversation with the public